Hello and welcome. Alan Plum here with a new project from Shed Engineering. Now I'm sorry we're not out in the shed at the moment. Somebody's having a barbecue and garden party, I'm afraid, and they're shouting and screaming, so we're in the office. I'm starting a new project, and that is to rebuild my model beam engine. Some time ago I set about trying to make a working model of a beam engine, and it was made just out of odds and ends and MDF. So the cylinder was 4-inch soil pipe, the beam is MDF, the flywheel is MDF, and then sort of aluminium bits and so on and so forth. And she works off the exhaust from a vacuum cleaner, and I've got plenty of videos documenting that. And she runs extremely well. She runs really well. One of the things about a beam engine is that they run very slowly, about 11 or 12 RPM. So a lot of the models that you see, the Stuart models, are often running far too fast, and I managed to get this one down to around 9.5, 10 RPM. But she's still not a steam engine, and so my ambition is to rebuild her. Sorry about that. My ambition is to rebuild her so that one day she might run on steam. Now, to do that we need to cast a lot of the parts and in aluminium. Now, I'm an absolute beginner. I've never done this before, but I've watched almost everything there is to watch on YouTube, trying to pick up tips and learn as much as I can. Now, I've got a bad habit of trying to improve things or look at things and see whether it can be done a different way or a better way. Now, whether that's a good habit or a bad habit, it's not for me to say. That's not to say that I'm suggesting or saying that your way of doing it is wrong. Not at all. If it works, then fine. I'm just looking at whether things can be improved. And if we look at most furnaces, because obviously to cast parts we've first got to build a furnace, and so that's my starting point. This is, oh, I don't know, how do you pronounce that? CL kind red. But there you can see that it's a metal container with some kind of refractory cement inside, but that's a little forge. This is, this is tool review, and again it's a metal container with refractory cement on the inside, leaving a cavity for the crucible. And most simple furnaces that I've seen are all of a similar kind of design. Here we've got a metal bucket. It looks though that is a galvanised bucket. I've always been told that galvanised metal gives off quite toxic fumes, but here they're using again a metal container with some kind of refractory cement inside. I've seen people just using simple sand and cement mixed with plaster of Paris. I've seen perlite being added, etc, etc, or possibly buying a proprietary brand of refractory cement, and they all seem very similar. Again, a metal container or oil drum, again with the refractory cement inside. But what I'm asking is what's actually happening to all that heat. To me it seems to be going into the refractory material, into the cement all the time. And if I can just show you a diagram, so hopefully this might explain my thinking and my reasoning and what I'm actually trying to say. Here we've got a typical oil drum, and it's being filled with some kind of refractory material. Immaterial, it doesn't really matter what that is. Now I'm going to be using charcoal or smokeless fuel of some kind, so I've represented that in the bottom. Now it could be a propane burner, but a similar kind of thing. You've got the heat in the bottom and the crucible. So what's actually happening? There's as much heat going into the refractory material, the cement or concrete lining, than there is going into the crucible, or that's the way it seems to me. If you're pumping air in, again you're just forcing air through the fire, and it's going up past the crucible, and there's more contact in actual fact, I would have thought, because you've got a bigger surface area onto the cement than you have the crucible. All that hot gas and heat is just shooting straight up and straight out, so it's in contact with the crucible for a very short length of time, and it's just whoosh straight up and out of the chimney. And it seems to me that you've got to raise the temperature of all this cement, because that's soaking up the heat, that's sucking the heat as much into the refractory material as it is the crucible. And I was wondering, is there a simple, cheap way that can be improved upon? So what I'm thinking is, can we turn that idea or that design inside out? So you've got your crucible, and you're going to blow your fire and flames in around the crucible. Now I know with propane you try to blow it in at an angle so that you create a vortex and try and get the flames swirling around the crucible. But as I say, I'm using charcoal, so you've got all your charcoal just here. You need some kind of fire grate underneath, but then you've got all the heat shooting up past the crucible, and we don't want it going into the refractory material. So what if we put the metal drum on the inside? If we put a metal drum or liner on the inside, now when you blow your air or propane in, then 50% of it will be going into the crucible, presumably a bit more, because it must be a bigger surface area, must be going into this liner, this metal liner just here. How do we stop the heat escaping? Well, why don't we have an air gap? If we have an air gap, and then put the refractory material there and have another air gap there, then you've got an air gap between your metal liner and the refractory material, and so all the heat has got to jump across that before you start warming this up. And so I'm thinking that has got to get a lot hotter a lot quicker. I'm then also thinking, is it possible to increase the surface area of the crucible? If you could put fins on the crucible, then the fins would actually capture more heat and transfer it into the crucible. And so that's my thinking at the moment, and so I haven't seen anything quite like that. As I say, I'm on a very tight budget. I'm trying to do it as cheap as possible, but I hope that sort of half explains what I'm trying to achieve. So this is the start of the shed engineering design of furnace. In Britain we call these thermalite blocks. There are other trade names that are available, but they're more or less a cement block with lots of tiny air bubbles blown into them, and they mainly used for their thermal insulating quality. Now, I don't think they're rated up to sort of temperatures of 6, 7, 800 degrees, obviously. So I don't know what will happen when they're exposed to that kind of temperature, but hopefully the liner will protect them to some extent. So as you can see, we've got two blocks laid side by side, leaving a channel through the middle, and that's going to be the air channel where I intend blowing air through and up under the fire. Or obviously, if you were using propane, then you could put the propane burner through that channel and have it directed up into the furnace. And at this stage I'm not sure whether I need a blower at each side, or whether one of the channels will be actually blocked off. Where my hand is there, you can see how I've shaped that section away in the middle, so hopefully we can get air going up under the fire evenly. This is a template I'm making out of some building foam. I've made a template, as you can see, 7-sided, representing the 7 blocks that will make the perimeter of the furnace, and to make it easier I'm just shaping this foam down to make a template. If you're not very good at keeping a straight line or cutting at 90 degrees, I've made this little block so that I can place the saw against it and it keeps it nice and true, making it a lot easier when we come to assemble the furnace. So that's the template centered on the base, and I'm using a 3-to-1 mix of sand and Portland cement to cement the blocks in place. I've cut them down, as you can see, to the required angle, and they're cemented in place around the template. And a second template placed at the top there keeps everything nice and straight and everything in line. I've then bound them together with some thin wire and proceeded to push more mortar into the joints so that the joints are completely filled. There you can see that the pointing of all the joints is complete, and there you've got the air channel leading underneath, and that's obviously looking down onto the inside with the air channels coming in from either side. So that's the basic furnace, and the idea is that the air will come in through one of those channels and then up through the fire. So rather than having just a blowpipe and getting a single hotspot, I was hoping with this design you might get a more even airflow through a fire grate and get an even airflow up through more of the fire. So this is some perforated stainless steel I managed to find, and I've just marked that out with some insulating tape as to where I need to cut it, and obviously that'll make the fire grate. And now you can understand how I'm hoping the air will blow evenly up through the fire, and that's the fire grate in position. So far so good, apart from there was a little air gap, and so the air would be blowing up through that rather than up through the centre of the fire. So it simply meant a scrap little piece of metal bolted onto the fire grate, and that actually sealed off the air gap, directing the air right under so that it's coming up through the centre of the fire grate. And there you can see how that little tab is going through the air channel, and that is just a picture looking through the air channel at the tab of metal that I've just bolted in place and the fire grate. So now it was a matter of, remember I said if you could put fins round the crucible to increase the surface area, then it would absorb more heat. Well, I haven't got a welder or anything like that, and I can't weld, so I've got this strip of metal. Now I know it's galvanized. I shall burn it off and stand well away, but I'm just concertinaing that backwards and forwards in the vise, as you can see, using some scrap plywood as spacers, bending it back and forth, and then opening that out, simply using a piece of pipe to open them concertinaed fins out, and then I wrap that around the bottom of the crucible. It looks a little bit like a pastry cutter in the end, and that is quite a nice tight fit around the crucible. So you can see the principle. Obviously the idea is that all those fins are extra surface area, capturing any heat that's passing up and rather than it just flowing up and out, I'm hoping that it'll pass more heat into the crucible, and in theory it should warm up a lot quicker and a lot faster, so you get up to melting point a lot quicker. Remember, I tied the blocks together with some thin wire. Well, that was only temporary to stabilize it very quickly. Once it had set and gone off, I got some thicker galvanized wire, cut grooves in all the corners, wrapped that around, and just twisted the wire together so that there was also sort of like a mechanical belt around the blocks, just to add stability, because obviously I'm expecting it to break down uh, over time. So now it was a matter of making the liner for the furnace. Now, I've never bought sheet metal before, but I went along to my local metal suppliers, A1 Metals in Peterborough, and simply pointed to some sheet metal in the scrap bin, saying, "I think that'll do me fine if you can cut that to 76B44," and chomp chomp through the guillotine, and it cost me £5. Uh, a friend at a fabrication shop was kind enough to roll it for me, although at the metal supplies they have rollers and they would soon roll it as well. So there we have the liner. Now, I didn't want it welding. Remember, I haven't got a welder, so there's no point in creating work. With it overlapping like that, then it's adjustable. And my idea was that I can now adjust it to the size I need just by wrapping some wire around it. So as you can see, it's a very, very simple design. The liner then just slides down inside the furnace blocks and sits on the fire grate. Now there, I think I've got it a little bit too big, and I adjust it down so there's a little bit more of an air gap. So the idea is that the heat is now coming up inside that liner, and the heat is being shared presumably roughly, let's say, 50-50 between the crucible and the liner. Now that liner should therefore get very hot very quickly, but it's going to have a job passing its heat on, because the heat has then got to jump across that air gap. So you can't get much cheaper than air as an insulator. So I'm hoping the liner will protect the blocks to an extent, because obviously at this stage I don't know how those blocks will stand up. That's just giving you an idea of the size, just in case anybody's interested. But as I said, the main idea is that insulating air gap, so that the heat is transferred into the crucible a lot more efficiently and effectively. The crucible is from a very, very old, I think it's cast steel, I don't think it's cast iron, fire extinguisher. Now, I didn't know whether I could get a lip on that, so I practiced using the top half. I haven't got pictures, I just dug a hole in the ground, put some charcoal in it, and a blowpipe, blew some air into the fire, rested the crucible onto the fire in the hole in the ground, and I managed to get the crucible sort of a good orange red, and was able to hammer a nice lip onto the crucible. So Hopefully you can see the thickness of that. That looks pretty substantial to me, and should last quite a while. And there we have the fins wrapped around the bottom of the crucible, obviously. And there we go. So that's about the complete build. I was concerned about the stability of the crucible on the fire bed. So out of a portion of the other fire extinguisher, I tried to open it up but failed miserably. But I cut some V sections in it in the hope that that would make like an upstand, so that I'd get a good depth of fire bed under the crucible, so that I could put charcoal around and inside it, yet the crucible would remain stable. Well, it worked to an extent, but it had got its drawbacks, which I will show next time. And I'm afraid that's all we've got time for. In my next video, I will be doing the first firing, and I make further improvements to the idea of the fins around the crucible. Remember, if you subscribe, you will have to click the little cogwheel next to the subscribe banner if you want to receive updates when a video is posted. I hope you found something of interest, and as always, many thanks for watching.